Hi, and welcome to This Is My Architecture. I'm Don, and I'm joined by Charlie with Equifax.
Hi, Don.
Hey, Charlie. Why don't you tell us a little bit about Equifax?
Sure. So Equifax is a rebuilt company from the ground up with an emphasis in enablement in the cloud.
Excellent. So tell us about the application that we're going to walk through today.
So the application we're going to talk about is myequifax.com. It's our primary asset for consumers to manage and monitor their credit.
Okay. So you want to walk us through from the consumer, their mobile device, to the architecture?
Sure. So from the top down, they can come in over web or mobile. They will come in through an application load balancer, which will lead into an EKS cluster, which is a composition of EC2 on-demand instances and spot instances from the spot instance marketplace in AWS. Following that, the multiple applications that are deployed on that cluster will actually make database connections to Aurora Global, and then also to a document storage engine for different, NoSQL implementations or storage documents. And so, with respect to Aurora Global, what we're talking about here is ACID compliance transactions, right? And then, of course, over on the document storage, we're talking NoSQL.
Okay, so things like credit reports, information about the individual are stored in the data stores that you have.
Correct.
So why don't we do this? Why don't we break this down and go through it piece by piece? So with respect to EKS here, so I see the on-demand instances and I see spot instances. So the first thing that comes to mind is, reliability.
That's right. And so Kubernetes gives us a lot of those constructs. And really where it boils down to is in the liveness and readiness probes with respect to EKS. And what those do is they tell EKS, the control plane, that those applications are ready to receive traffic.
Okay, so from a cost optimization standpoint, it sounds like you can blend different instance families across different AZs to tap into different capacity pools?
Absolutely, yeah. So when we talk about spot instances in the AWS marketplace, and so just to take it from the from the top down, what we're talking about here is really a 60-40 split with respect to spot instances and 40% on-demand instances.
Okay.
So we've got spot on this side, and we've got on-demand on this side. And when we talk about the different architectures and the different capacity pools that are available across different regions, that's really where the Graviton2 processors, ECR with manifest list, building those Docker images for multiple architectures with Docker X.
Okay, so I have to imagine you have quite a few consumers that are hitting this. So again, back to reliability. You mentioned Graviton2, so we have ECR. Can you talk about kind of how your pipeline, what it looks like to deploy?
Absolutely, yeah. So we have a global pipeline that actually, so I'll write this out here. We've got a global pipeline, build pipeline that actually runs all of our SDLC, our unit test, integration test, also deploys across multiple regions and multiple accounts into this exact same architecture across multiple regions.
Okay. All right. So why don't we move down to the persistence here? So we have Aurora Global. So I assume we're talking multi-region.
Correct.
Right? That's clearly going to have an impact on your applications. Can you talk about what you had to do to actually enable that?
Absolutely, yeah. So Aurora Global is a multi-region replicating transactional database, SQL database. The particular flavor that we're using is Postgres. And so it's Postgres over the wire from a driver compliance standpoint.
Okay.
So you can imagine we've got our applications running on EKS. Those are actually talking to Aurora Global instance over Postgres. And then that data is actually replicated on the AWS backbone between the Aurora Global writers and readers.
Okay.
And so to answer your question, the applications actually implement a dynamic data source. And so and we drive those configurations from a configuration server. And so really what happens is, let's imagine that we're in the West Coast and there's a failure on the writer. The property that's served from the configuration server to the application is the only thing that has to change.
Okay.
And then through dynamic refreshing in the application context, it will fail over and start talking to the writer in the different region.
Interesting. So I think what I'm seeing here is a combination of an event-driven configuration, an event-driven notification likely, because spot instances are going to have a termination notification. Can you talk kind of how those pieces come
Sure.
together to create this highly reliable database?
Absolutely.
architecture?
So AWS actually gives us something they call the node termination handler. And what that is that's just a pod that actually runs on our clusters, or a number of pods. And what that pod does, and we'll call this the node termination handler, what that does is it listens to events from AWS across the control plane on when one of these spot instances will actually be reclaimed.
Okay.
And you only get a 2-minute warning.
Okay, so
so
you're
you-
able to, with your architecture, you're able to react quickly enough?
Absolutely. So when that event occurs, the pods that are actually running on these spot instances, and we'll just throw out some pods out here for these applications. And remember, those liveness and readiness probes are actually configured as well. There's a 2-minute warning. That node gets reclaimed, and those pods, the node termination handler will reshuffle those pods over to a running node as that node gets replaced.
Interesting. So what's next for the architecture?
So we're going to replicate this globally. And we're going to take this, so we're in the UK and Australia, and of course in the US and even Canada. And the savings that we actually see here is about a 60, 70, even upwards of 80% savings by going with the spot instance model with a combination of the EC2 on-demand instances. And so what we're really playing with here is this ratio. How much spot instances or how many spot instances can we use versus how many on-demand instances can we use to optimize that cost savings.
Right. Well, thank you very much for sharing this innovative architecture. Taps into a lot of the well-architected framework pillars that we emphasize. So we have cost optimization, we have reliability, and this is very an interesting approach to having both from a compute standpoint and a persistence standpoint. How you've handled that.
Sure.
Thanks for your time today.
Sure.
And thank you for watching.